Today, the topic is going to be, again, tips and tricks in SimSolid, and the focus is going to be on welds. We're going to talk specifically about seam welds. We can also do spot and laser welds in SimSolid, but I think for this group, this is going to be probably the more interesting topic. Welds in SimSolid are defined by some section size and length along edges between parts, and the weld material properties are going to be taken from the adjacent parts. So with this approach, those stress contours are going to be available in post-processing within the weld body. Why would I use welds versus standard connections? Well, the reality is we can and probably should use both depending on our assembly. The standard connections we can apply, as we've already talked about, sliding and separating contact, but welds are always going to be perfectly bonded. So we're not going to be modeling explicitly things like weld failure in here, but welds can provide a more accurate representation that more closely matches reality than if you were to just put on a bonded contact. And then we also get the ability to contour stress on there. So let's go hop over into a demo to show how we would set this up. Open up SimSolid and we'll start with just a geometry file. I like this example because it goes through all of the different ways and approaches that we can set up welds. Turn on the colored representation so we can see the difference between the parts. And we will notice here that there's already some welds that have been modeled in CAD. We certainly can take that approach, but we'll also talk about how to automatically create these connections if we didn't model those explicitly. We'll be under the same connections. All of our connection types will be under this menu, and we will be here in seam welds, create a new seam weld. All of these different tabs are going to tell us or guide us through different workflows. Let's drop this section size or the minimum length down a bit, and we'll bring our section size up. The easiest way here for just welding two parts together is going to be choosing a master and a mate. Say find welds, and it will find, based on proximity here, these adjacent parts. We could also do intermittent welds. So if we wanted to do some segment length and then have a break and then more segment, we could say find welds here, and I probably should make these further apart so you can actually see this. So let's go. So the section size needs to be smaller than the weld length. All right, if we say OK here, then we see that we have these intermittent welds. Let's delete these and try a different approach, maybe something that scales a little better. I don't have to go in and individually pick parts. Let's go to a group weld here. So in this case, we're going to just control and select a lot of different parts, say find the different welds, and it is going to find welds between all of the different parts that are adjacent. We'll hit OK here. These are very big welds, but we can always adjust the size downward. And we see we've got all these connections between these adjacent parts. Let's go ahead, get rid of these and try a different approach. In this case, we are going to drop this section size back down so we can see what's going on a little bit better. And now we're going to do weld by lines or edges. So in this case, we'll simply select lines where we want to find the welds. We'll have between these two parts, and over here we will have two different welds between these three layers. You'll notice some of them are in red. That is just whichever one is active, and I have highlighted here. So it's not that there's a problem. It is just that we have selected that to focus on it. Right, and we've even got a weld being created between welds. So if you're going to take this approach and you already have 3D CAD for the welds, perhaps delete those out before you do this, or just come in here simply and delete that extra weld that was made. And the last option here is going to be selecting the parts that are already modeled as welds. So in this case, we would select this guy here and create our connection between these two plates. In this model, somebody has been diligent and named most of our welds appropriately. So we can also search by part name, say find parts. We get all of these different fillet welds that show up. We can say find welds, and it will make welds out of these entities. You'll notice that 3D geometry that was originally there has been removed so that you don't end up with duplicate stiffness here between the connection and the geometry that was existing. One potentially interesting thing here, if you're trying to do planning and estimation for the total weld length, you can right click on all of your seam welds and say info. It will give you the number of welds in your model as well as the total length of them. So perhaps that is useful for people to have for planning purposes. Let's take this over to maybe something that looks a little more realistic for day to day. I already brought in that skid model, so let's go ahead, close this one. Open this platform. We're gonna actually open that as a geometry file so that we bring it in from scratch. We're going to hold off on making those automatic connections and assume that geometry is fine. I've already checked it. Now we're going to go in and make those welds, and I'll do it by group. So I'll say I want to do these particular pieces, and those are the only ones that I am going to model with welds, at least for now. They find welds, and you can see in green here the outlines that are made and the connections that will be made. So we'll hit OK. And now if we want to model the rest of our structure and just use some kind of bonded or sliding contacts, we can use this automatic connection tool and say, I want to connect all the parts that are not already connected by welds, so just ignore that. In this case, these interfaces are relatively small. I know just from trial and error previously that I'm going to need a higher resolution level in order to capture and get the appropriate number of points for this particular model. Not always. So we'll go ahead and click OK. It will find and evaluate these connections, classify them. These are done. We can show all of our regular connections, and we notice that we don't have any kind of bonded contact being made here because this connection is already represented. Just to finish this out, I will apply a very similar setup to what we did in week 1, just a structural linear, apply steel, just some kind of generic steel to all of the parts. Come in here and select these faces. And we also constrain the bottom of this ladder. And then we will have someone or a couple people even maybe standing on this platform. Just for the sake of speed here, we are going to go ahead and run this just with the adapt for stiffness. One thing that I want to point out, if anybody goes and does this model on their own, some of these connections before I showed that I like to come in here and check the locations or check the connections and see the resolution per part. So when we sort here, we do have some that only have, for instance, 4 points. In this particular case, when you go in here and actually review the part contact conditions, you see that there are full contacts made. The issue is more that they're separated out into different contacts. So it's not that we're going to have this hinging or not fully connected. It's just if we want to go in and do some kind of contact pressure analysis, we're going to have to consider multiple contact faces. They're just spread out over different connections. This will take potentially a couple seconds longer to run just because we have those higher resolution connections that we've made in the model. So now we have our results. We can come in here and plot, for instance, stress, analyze this, do our post-processing like we would any other model. But you'll see these welds still have a stress contour on them. We could go in here individually and choose a stress contour and pull stresses from the welds just like we would any other part. I will mention welds are notoriously difficult to model, so certainly validate these against probably a full CAE model, or you have them some kind of analysis results.